Hello guys, and welcome back to another episode of my ability system series. In this and probably the next two videos, we will finally start to create the actual skill tree, where you'll be able to purchase new skills, drag them onto your hotkey bar, and also upgrade the stage of your spells so they might deal more damage or have less cooldown and so on. This video will deal with the preparation that we have to do for our skill tree. And then in the next video we'll start to create the actual sub widgets that we need and slowly start putting them together. For the skill tree we will use a lot of new textures, so I made another asset pack for you. And let's import that together this time. So let's go into our textures folder, make a new folder here for the skill tree. Then in the asset folder that you just downloaded, we will select everything except for the level border, drag that into our skill tree and wait for it to load. Then we will right click, asset actions, and bulk edit via property matrix, expand the level of detail and set the texture group to UI. Then go to compression. Compression setting should be user interface. You can hit Ctrl S then to save all of those, close it. After that we'll go back to our textures folder and just drag and drop our level border into it. And here we'll do it manually, so double click, compressions should be UI and texture group UI. I'll save it. And that's it for importing all of the asset pack textures. One of the few preparation things we need to do is change the way our XP system works currently. You might have already noticed we can gain XP, which is completely fine if we kill enemies, for example with our arcane missile spell. But currently we do not have any level and nothing happens when we reach the 300 XP here. So let's fix that first, because for the skill tree we will need levels. Every time you reach a level up you will gain 1 skill point that you can spend on the tree. So first off, let's go to widgets and into our main widget, because we need a way of displaying the level. Let's go to the XP bar here, set the Z order to 2. Then let's search for a border, drag that into our canvas, and let's call that the level border. You can make that a variable if you want to show or hide it, depending on whether the player needs to see it right now. I would just keep it visible for the entire time. We'll anchor it to the upper right anchor. Set the Z order to 1 so that it will still be beneath the XP bar here. We'll set the position in X to -200 and in Y to 40. Then set the alignment in X to 1 and leave it at 0 in Y, and the size will be 132 pixel by 29 pixel. So expand the brush, and here we need to select our level border. Actually it looks like the position in Y isn't quite right, so let's increase that. Maybe it's 55. Yep, that should work fine. Expand the padding, and we will set the padding to the left to 0. To the top will remain at 2, right will become 20, and bottom 0. Also, we will set the horizontal alignment here to right and the vertical to bottom. Alright, then let's search for a text and drag that onto our level border. Make that a variable called the level text. Default text can be something like 16. We'll lower the font size to 18. And let's give it a shadow. So let's go to the shadow color, make it opaque, and maybe select something like a dark orange. Compile and save our main widget, then we can close it. And let's open up our skill character. So adding a level system is extremely simple. We'll just add one variable, call that current level, make it an integer, compile, and the default value should be 1 unless you want to start with level 0, that's also fine. Save, and then we need a new function here called update level. In here, let's just get the main widget and then our level text from that. We want to set text and get our current level, then just drag that into the in text and it will automatically convert that for you. Expand it, uncheck use grouping, and collapse it again. Right? Then we'll add another function called increase level, and this will just set the current level to the level +1. So we'll get current level, search for plus, integer plus integer, and then connect that. After we did that, we also want to update the level. Alright, pile and save. Now the thing is that when our XP is animated, it will never be able to go above the maximum value. And what we need to do is store the rest. In case that we reach a level up, we need to be able to store the XP that needs to be added afterwards. So to do that, let's go into modify stat. After our first branch, so on the true path, we'll check whether the stat equals EXP, because for the other stats we don't need such a system. So add an if for that. But before we connect it to the branch, actually we want to add an end statement, because we need to check that it's experience and that we would reach a level up. So we need to compare the current value plus the local buy, and need to check whether that is greater or equal to the maximum value of the stat. Then connect this to the end to the condition. If it's false, we will just proceed like we did before. But if it's true, we know that we'll reach a level up. So what we can do is add a new variable here called restXP. And we need to set that on the true path. Connect that. And after we set it, we just want to proceed with setting the local lerp alpha. Now we will be setting it to the restXP we currently have, plus integer plus integer, and what we want to add is the current value plus local buy minus the max value. Connect that up here and then to the set restexp. Compile and save this. Then we need to handle increasing the level once we gain the necessary XP. Fortunately, we've got our function here on stat lerp end, which will be called when the animation for EXP is over. So let's open that up and let's check whether the stat equals experience. Then add a branch for that at the very end of the function. If it's false, we can directly go into our return node. Same as before, we not only want to check for the experience, but we want to connect the second condition, so add an end. Then we want to get stat. Stat we can just set to experience, then break it. And we want to see the current value and the maximum value. Everything else we don't really care about right now. And we want to check whether the current value is greater or equal to the maximum value. Connect that to the end and to the condition. If that is true, means we have to call the level up. But before doing so, we want to remove our current XP. So we'll just modify stat. Set the stat to be experience. Animated will be left false because we want that to happen instantly. And the buy will be our current value times -1. So we will subtract as much XP as we have currently. So now our XP was resetted. After that we can increase the level. And then we need to check whether we've got rest XP that we need to add. So let's see whether that is greater than 0. add an if statement. If it isn't greater than 0, means we don't have any rest, so we can just return. But if it is, let's get our rest XP here, promote that to a local variable called local rest. Then we want to set the rest XP to 0, because we're going to add it in a second. And then we will call modify stat, stat being experience. This time we can check animated, and the by will be our local rest that we just stored. After that we can simply return. Right? Compile and save this. Now let's go back to the event graph, because we need to call our update level function right after we created the main widget, maybe here, just before we add it to the viewport. We can call update level. Alright. Currently our monsters are all giving us 100 XP, so we'll never see the case that you gain more XP than you need for the level up. Let's fix that. Just open up the master enemy blueprint, and here we've got our EXP for kill, set that to 200. Compile and save. Now if we start the game, first off we see that we have level 1 currently, which is all correct. Then let's select our spider here and we can kill it. See, we've got 200 out of 300 now. So what should happen when we kill the next enemy is that first we reach the 300 XP, the level will change to 2, then our XP will be resetted and we'll gain another 100 EXP. And it's doing that perfectly fine. Alright, so that's it for completing our level system and experience system. We can close the game now. Since we will be adding the skill tree in a second, we don't need our starting skills anymore, so let's just open up the third person blueprint or skill character and delete the generate starting skills call that we've got. Then we can remove the entire function, generate starting skills, and finally our starting skills array. But we want to have another variable here called learned spell classes. The type for that will be a master skill class, and it will be a container and not an array but a set. So we've never used sets in this series before or in general on this channel. What a set is basically, it's an array except for the fact that you can't have duplicates in there, so every element is unique, and it doesn't have indices, so you don't really care about the order of things. You just want to see whether something, in this case a class, is included in it. So that makes it the perfect container for something like that. We just want to see whether we ever skilled the class, and we don't care about when we skilled it. Let's close the skill character for now. Go to our blueprints folder, and we need a couple of structures for the next videos. Most of them probably won't make sense right now, but I'll make sure to explain what they do in detail once we've got the actual widgets working that use those structures. So let's create the first structure here. It will be called s_subtree connection. Basically, we will generate our skill tree during runtime, and the skill tree will consist of two main components. So you've got the skills that are aligned there, and there are connections between those. For example, if you need to have learned Arcane Nova before you can learn the Arcane Missile, then there would be a connection between those two that indicates this. And to generate those connections, we need to store a couple of things about them. So first off, we need its position. Variable type for that will be vector 2D. Then another variable called size, also a vector 2D, and a third one which will be transform, so rotation and so on, and that will be a widget transform. Save it and close the subtree connection. Let's create the next one, blueprint structures s_subtree skill. So for every skill that we'll generate, we also want to keep track of the position in the skill tree. That will be another vector 2D. And we want to know which spell is assigned to it. So that will be a master skill class that we'll just call spell class. Save and close the subtree skill. Next structure will be called s_subtree content. So we will have various subtrees, and every subtree will have a list of skills, which will be s_subtree skills, so make that an array, and connections, so that will be an array as well, but not for subtree skills, but subtree connections. Okay, save that. And finally we need another structure. I'll just duplicate the subtree content, holding down Control and W, and call it s_tree category. Open that up. First variable will be the name of this tree category. That will be a text and a single variable, and then it needs the content, and that will just be the subtree content and a single variable. Save and close the tree category. Alright, that's it for all of the structures. As I mentioned before, I will explain them properly once we've got to use them. But now we should go into the blueprints folder, right click, create a new folder for components, and we will make the skill tree a component that you can just attach to the third person character. So create a new blueprint class and choose the actor component as the parent class, then call it BPC for blueprint component underscore skill tree. Double click. Let's give that a couple of variables. So this one will have a variable called player character, and the variable type will be skill character reference. Then we need the skill points, so we store those on the skill tree. Make that an integer, editable and exposed on spawn. Compile it, give it a default of maybe 2, whatever you want to start with. And then we need the various categories that this tree has. Categories, also editable and exposed on spawn, but the variable type here will be s_tree category, and it will be an array. Right, compile, save this. Then on event begin play, we will get the owner of this blueprint component, cast it to the skill character, and if that cast succeeds, we will set the player character reference to our skill character. Let's also add a function called player learned spell question mark. It will be a pure function with one input and one output. The output will just be a boolean called out question mark, and the input will be the spell, so a master skill class. And now it comes in really handy that we set up the set before, so we can just get up their character, get the learned spell classes, call the contain function, contains item, and plug in our spell, then just connect it to the output. Pile and save. And let's add another function called add skill points, which will have an input of the type integer called amount, and right here we will just set the skill points to skill points plus the amount for now. Later we will add a bunch of other stuff in here. Close it. Then I want you to go to the skill actors and open up the master skill, because here we should set the current stage index default value to -1. That is only so that when an actor is spawned, that doesn't directly mean that you already have access to the first stage of it, which will come in useful when we create the skill widget later. And finally, let's save all of the other spell classes. Then let's go into our skill character, and first off we will add a component, search for our skill tree. Now we've got that in here. We can rename this to player tree, and if you want to, you could adjust the skill points and categories, but we won't do that right now. But then let's go into our increase level function, and after we updated the level, we can drag in our player tree and call add skill point. Now you can define how much skill points you want to add every time you level up. I'll just set it to 1. Alright, compile and save this. And for the moment, that's everything we can do for preparation work. So see you in the next episode where we will build the widgets for the skill tree.